Good morning. I welcome all of you to the seventh part of degree calculations. Last time, when we were doing degree calculations, sixth part, we were trying to make the development of a oval shaped job. Actually, we can say about it is an oval shaped job because its shape was like this. There were two half rounds. One half round is here and the next half round is here. In between there was a straight portion. If there is a straight portion, we can't say about it is a oval shaped job. Anyway, we were trying to find out the development of this kind of one job. Two, three methods we have used to find out its developments. Two, three types developments we have done. This shell's measurements, radius is 600. Just check the measurement wherever it is coming from and wherever it is finishing. It is from center to the outside. Arrow is indicating it is outer radius. I have told you about this all. But we shouldn't take outer radius. We shouldn't take inner radius for calculations. And we have to take in medium radius. It means from center to the middle of the thickness. This thickness is 20 mm. I don't explain those all now because I had explained this all last episodes. So I just come to the point. You just recognize its outer radius is 600, its thickness is 20 mm, and straight length in between two half rounds straight length is there, that is 700. It is the plan of the job. You know what is plan? Plan means top view. If we look from top side, this kind of vision we will have. And if we look it from front side, in this side, if we look from here to there, we will be seeing this kind of vision. It means this 2000 is the height of this shell, oval shaped shell. You know why have I indicated this dotted line? Because it is the thickness from here to here is 20 mm. It has been indicated. But when we look from here, we can't see inside. We can see outside only. So we have used thick line for outside. We have used thick line for outside. And inside, we have used dotted line. It is the real method of engineering drawing. You too have to follow it. I have done this all in freehand sketches, but when you make the drawing, you have to take proper scale, proper compass, proper things you have to use, and you have to do it with proper scale. Okay, come to the point. Next time when I will be doing this kind of jobs, I won't write its plan, elevation, and I won't waste time because we have to study developments only. So next time I will be showing this kind of one job only. Both jobs are same. For calculations, we shouldn't use the measurement 600. Instead of 600, we have to use the measurement decreasing thicknesses half. Pi d means, what is pi d? D is diameter. It shouldn't be major diameter and it shouldn't be minor diameter, and it has to be medium diameter. Medium diameter means it is the diameter which is coming from the center of the thickness to the center of the thickness. That is medium diameter. If it is medium diameter is from center of the thickness to the center of the thickness, its half will be its medium radius. Medium radius will be starting from the center of the thickness to the center of the circle. It means medium radius will be the half of the medium diameter. Okay, it means if it is 600, what will be its medium radius? It is 20 mm. 20 mm's half is 10 mm. If we decrease 10 mm from the 600, we will get 590. So this is the original measurement we have to use for calculations. With this calculation, using this 590 measurement, it is the radius of medium radius. It has to be the proper radius we have to use in calculations. If we use this measurement, we will get proper developments. Okay, next time when I will be showing one job, I won't indicate this plan or elevation. I will be saying rough sketch I will make, and I will tell its radius is 590. Then you have to understand it is in the outer radius or it is the inner radius, and it is medium radius, and its height, its straight length is 700. I have indicated it, and here I didn't indicate one elevation here. Instead of elevation, I just wrote height 2000, because we are studying development only. We are not wasting our time drawing these kind of wall pictures. Next time I will be giving you this kind of one diagram only. With this diagram you have to find out development. So last time we had made its development. We had made this kind of one development. That development is starting from here and it crosses from here to here. It is coming to here. Afterwards, when it reaches here, one development has been finished. It's 700 is its straight length. Straight length means from here to here is 700. That is straight length. After straight length, one radius, one rolling direction is coming. We have indicated it. From this dotted line to this dotted line is rolling. Instead of rolling, I have written a word R. This portion, the dotted line from dotted line portions, in between dotted lines, we have to roll. And in between this dotted line and this sticky line, there should be straight portion. That portion we shouldn't roll. It should be straight. And this portion also should be straight. Instead of straight, I have used the word S. After S, it means here first straight portion is coming, then rolling is coming, again straight is coming, afterwards again rolling is coming. Here also I have indicated it like that. Straight portion is coming, afterwards rolling portion is coming, then straight portion is coming, rolling portion is coming. Its measurement also, I am not describing about it, because last time we have told about it. The straight length is 700 and the radius length we had found out last time. It was 1853.5. How do we find out this measurement? You know those all. We used the formula pi d. When we used the formula pi d, we got the perimeter of this full circle. Afterwards, we divided it with 2, because we need half round only. When we divide it with 2, we get the measurement 1853.5. If it is 1853.5, this one also will be 1853.5. From this dotted line to this dotted line, 1853.5. Same thing is coming here. From this point to this point is also 1853.5. These two are rolling. These two places we have to do rolling, and these two places we have to do straight. We shouldn't roll there. Okay, this was the one method we had used to find out development. I had told you about the goodnesses of this development and its faults also I have indicated. So many goodnesses I have told, more faults I could say about this development. So what we have to do? We did one more development. It was this development. What is its speciality? If this development is from only one plate, this development is from 4 plates. 2 numbers we have to make like this, and 2 numbers we have to make like this. It means straight portion, two are there, one straight portion and another two portion. We cut these portions and we make two plates. One plate is like this. Its length and width is 700 into 2000. Here we have indicated 700 into 2000. This measurement is 2000. I have indicated it 2000. Why is it 2000? It is the height of the job. It is the height of the shell. Height of the job is, I have written here 2000. I have indicated in elevation 2000. So in development, we will be rolling it in this way, but this measurement 2000 will be constant. It won't have any changes. So we can develop in this way. Its faults and goodnesses I have told. It is also having a lot of goodnesses and faults. I have indicated about it also. So many goodnesses I have told. More than goodnesses, I could say faults. So two methods I have told. Afterwards, I told about another one method also. I think you understood about this. Two straight pieces have to be made in this way, 700, 2000, and two pieces have to be made in this measurement, 1853.5 into 2000. That is for rolling, 1853.5. This kind of two portions. It means two plates we are cutting in this way, two plates we are cutting in this measurement. Then total 4 plates we are cutting. After making, we will keep it in a leveled platform and we are tacking it, we are welding it. Afterwards, we will get this kind of one job. So one method is this one, second method is this one, third method I told, when we take this kind of measurement, I told the problem of rolling. When we roll, plates last end we won't get rolling. I told you approximate 100 mm we won't get. So I had recommended you take 100 more mm from half round end. 100 mm extra we have to take here. 100 mm extra we have to take here. It means there is no need for us to hammer there. There is no need for us to bend there. We can directly roll, avoiding the portion of 100 mm. That is one method. So whatever perimeter we have used from here to here, with that perimeter we have to add 100 mm here. We have to add 100 mm here also. If we add 100 plus 100, 200 mm in rolling area, we have to decrease 100 plus 100 mm in straight area also, because we will lose 100 mm from here, we will lose 100 mm from here. So we shouldn't mark the measurement as 700, we have to use 500. It is also a third method of making its development. In this way, we have to cut 500 into 2000's two numbers. Both are same. What is the difference? From 700 we have decreased 200 mm from both sides. From here we have this place we decreased 100 mm. From here also we have removed 100 mm. So this 700 have become 500. 2000 won't have any changes because it is height. In this way we are decreasing in this direction only. When we look from top side in rolling direction, we in perimeter side we have added 100 mm, 100 mm, and straight side we have decreased, removed 100 mm, 100 mm. So there is no need for us to think about it more. From 700 we have decreased 100 plus 100, 200, then it has become 500. So in this way, 2000 into 500, two pieces we have to take. It shouldn't be rolled, it should be straight piece. And from this portion, rolling area, rolling plate, we have to add 100 plus mm. Earlier we were taking 1853.5 width. From here to here it was 1853.5. Now we have to add 100 mm here, 100 mm here. If this 100 mm is approximate, in different rolling machines it is really different. If you like to add 150 mm both sides, you can add 150 mm, but you have to remember, you have to decrease 150 mm and 150 mm in straight portion also. Now, as a general method, general um, procedure everybody follows, I just told about this 100 mm increasing of this 100 mm in rolling area and decreasing 100 mm from straight area. Okay, now I told three methods for making its development. It is one method, it is a second method, it is the third method. Another method is what is here also I have told goodnesses and faults. Here also I have told its goodnesses and its faults. Here also I have told its goodnesses and faults. So many faults I could say about it. Goodnesses are also there, but faults are there. Its measurement, just to check, 1853.5, we added 100 mm here, 100 mm over here. If we add 100 mm two times, it becomes 2053.5. It is the development. This kind of two pieces we have to make, this kind of two pieces we have to make. In these two pieces, last 100 mm we shouldn't roll. Last 100 mm we shouldn't roll. I have indicated it here. Last 100 mm. In this area is the area of straight area. I have written yes here, straight area. This area we shouldn't roll. This area also we shouldn't roll. Here also I have written yes. Yes means straight. It is 100 mm. From here to here 100 mm. This is the proper indication of measurements. I have just made it with the hand sketch I have made, but when you do it, you will have to do it with proper scale. I have told you it should be thin line, and I have told you from the original job there should be a 3 mm gap. Afterwards 10 mm thin line has to be made. This is the proper indication for measurements. I am not doing a separate engineering drawing class. Whenever I take the classes of pattern developments, in between I will be telling about this kind of engineering drawings. Okay, so this kind of two pieces we have to make, this kind of two pieces. This jobs some description I have given here only. It is for your acknowledgement. 100 mm extra, here also 100 mm extra, that is straight portion, and the center portion from is from dotted line to dotted line, that has to be rolled. That measurement is 1853.5. We had told you 1853.5. Okay, so three methods perimeter making development. One method, second method, third method. Fourth method is this one. It is when we take separate pieces, we had to take four pieces. One straight piece, second rolling piece, third straight piece, fourth rolling piece. What it is having so many faults and goodnesses. One fault is, and it is a major fault is, we have to when we set this one in a platform, we will have to give supports for each other, supports for each one. It is very difficult to develop, it is very difficult to set in platform. But if you take two pieces, it will rest properly. Two pieces means center of this 700 if we start, and it is inset the center of another 700 mm. If you make this kind of one job, after rolling, if you keep it in a ground, it will stay straight without any falling. We can set it some more easily. That development is here. It means from center we start. So what is the center of 700? 350 mm. So we have to add 350 mm with this half perimeter. Here also we have to add 350 mm. That I have indicated here. If we add 350 mm plus 350 mm, this measurement will become, what will be, 2553.5. Because original perimeter is 1853.5. With this one, we have added 350 mm here. We have added 350 mm here. 350 plus 1853.5 plus again 350 is 2553.5. It is a small measurement. So I don't use calculator, and I am not teaching you because you aren't a LKG student, you aren't a LP student, you aren't a UKG student. I don't spoil time. You can, if you like to just check, you can use your calculator and check. This 2553.5 we have got. When we added 350 here and 350 here, it is a development. This kind of 2 has to be made. No need for making 4 pieces like this. 2 plus 2 we have made 4. 2 plus 2 we have made 4. Here we have made only 1 piece. For making this development we have used only 1 plate. For making this kind of development we have used 2 plus 2, 4, total 4. For making this development we have used 2 plus 2, 4, total 4. But for making this development we can use only 2 pieces, because 1 piece, if we start from the center, it reaches and covers center. It means this jobs, this plans, half portion has been completed if we roll 1 plate. Okay, so its measurement will be 2553.5 into 2000. 2000 is its height. This kind of 2 pieces we have to make. Its description I have given here. From here to here, no need to roll. It should be a straight piece. It is 350 mm. From here to here, no need to roll, that is straight portion. Then rolling comes. That rolling is 1853.5. From dotted line to dotted line, we have to roll. I have indicated R. It indicates rolling. In this portion we have to roll, and in this portion from dotted line to this thick line we shouldn't roll. It should be a straight piece. Like that here also, from dotted line to thick line we shouldn't roll. It should be a straight piece. So yes, I have indicated. This measurement from here to here is 350. Here to here is 350. Then total, if we add 350 plus 1853.5 plus 350, we get 2553.5. It is also another method. It is also having a lot of goodnesses and faults. Different companies are having different facilities and different. Some companies will have so many machines. Some companies will have so many areas, so many good platforms. Some other companies won't have more machines, more tools, more good platforms, more facilities. So according to the facilities and according to the facilities of your company, you have to take the proper estimation, and you have to find out which development we have to use for our company to get more speed, more finishing, more accuracy. Sometimes it may be good for your company, sometimes it may not be good for you. It may be good for you, sometimes it may not be good for you. This may be good for you. If it isn't good for you, sometimes it may be good for you. If it isn't good for you, one more method I am indicating, that is this method. I am telling the 5th method now. 1st, 2nd, 3rd, 4th, 5th method. If I do this work, if I make it do, I will be doing this method only, because it is having a lot of goodnesses. It means it is also having faults. I know. I will tell about the faults and goodnesses, but goodnesses are more. So I will do this one also. What is this? Come. For making that kind of development, we start from this portion. This portion means end of one straight portion, and it reaches here. We shouldn't stop. Again it reaches this portion. This portion is the end of the rolling. It means in this area there is a full straight portion and there is a full half round portion. It means it starts from here and ends here, one portion. That kind of two we have to make. Another portion starts from here and it ends here. Both are same. Anyway we can make. It won't have any problem when you roll. You can set anywhere. So many goodnesses are there, but it is having a problem. It is having two welding. That is one problem. What is another problem? I can't say more faults about this kind of method. For making this one, we have to use this kind of development. 2553.5. It is same as this one, because here one half round rolling is there and one half of the one straight portion and half of the one straight portion is there. Here also same things are there. One half round rolling is there. Here two straight portions are in its both ends. Two straight portions, half portions are in both ends. One straight portions, half portions, two portions are here. One half portion, it's half. This halves, two parts, both are here. One half is here, one half is here. These two halves have come in one side. It's a description I have given. If you check this description, you will recognize this one. From here to here is straight. I have indicated S, that is 700. It means from here to here is 700. We shouldn't roll there. It should be straight. That is straight. From here to here is 700. And from here to here is, there should be rolling. It is 1853.5. You know, it is 1853.5. From here to here is 1853.5. You know about it. Earlier episodes, so many episodes, I have told you how to find out perimeter. It is no need to find out full round, half round. First we find out perimeter pi d, then divide it with 2. Then we get this measurement 1853.5. No need to explain about it again, because here also we told about 1853.5. Here also we told about 1853.5. But it is, I have written 2053. Why? We have added 100 mm here and 100 mm here. But actually the center portion, rolling portion is 1853.5. 1853.5 plus 100 plus 100 is 2053.5. Actual rolling area is 1853.5. Here also rolling area is 1853.5. Here is also your rolling area is 1853.5. Rolling area, it is rolling area and it is also rolling area. Okay. So it will be having so many goodnesses and faults, but so many goodnesses I can find out. From two pieces we can make same type of marking. We can avoid unnecessary weldings, because if we make it in this way, we have to make this kind of two pieces. We have to make this kind of two pieces. Total 4 pieces. In each portion we have to mark, we have to cut, we have to bevel, we have to set, we have to tack, we have to weld. Afterwards, sometimes it may have distortion, it may have shrinkage, it may have some other portions. Those portions have to be chopped, those portions have to be grinded. Finally we have to give it for welding. So many weldings are there, but here only 2 weldings are there. That is, it's one goodness. And another thing is, one area is full of rolling, another area is full of straightness. So in between some other problems may not happen, because if we try to find out this kind of one job. This kind of one job, it is from one plate. It will be very difficult to roll from one plate. It's because of the length and width. We will have to use more manpower. We may take more time. More facilities has to have. So I prefer this method. Next time when we will be saying about this method only. In next episode I will describe about its different operations. Now just check what is this measurement 2553.5 from here to here is 2553.5. It means from here to here is 2553.5. 700 plus 1853.5 is 2553.5 and its height will be 2000. This kind of two pieces have to be made. That is also a goodness. Only two pieces we have to make. So I would like to make this kind of one job. If I make it in one company, I will try to make it in this way. Okay, I will find out its estimation, which method should be good for this operation. Sometimes if you take the proper estimation, you too will prefer this method. Anyway, next time I will be saying about this method only. For making this one, when we take I would like to say something about it. If we cut this plate in this way, when we look from here, we will see one measurement. What is this measurement? From here to here is 2553.5. 2553.5. This view I can see. From here we look, we will see its thickness. Okay, 2553.5. I have indicated it here. It's when we look from there, we will see its top height as 2553.5. From here to here is 2553.5. I didn't use the engineering method to show that measurements. Actually I had to use one line here, I had to use one line here, afterwards one thin line had to be used, afterwards I had to write, but it is for teaching only, so I didn't use. But when you draw the engineering drawing, you have to draw it with full of scale. Okay, 2553.8. Its thickness is 20 mm. Its thickness is 20 mm. It is the view from here. When we look from here, we will see its thickness 20 mm and its length also we will see that I have indicated here. And this portion is straight. This portion is straight. From here to here is straight and this portion is rolling. But if we make one plate in this way, after rolling, we can't weld this one because it isn't having bevel. We can't weld. There should be bevel because it is a 20 mm plate. For making bevel, what we have to use? We have to do this kind of bevel. We have to cut in this V direction. Both sides we have to cut. What is its length? 2553.5. Here I have indicated 2553.5. From end to end is 2553.5. From here to here it should be straight. Here also same to straight. And from here to here it should be rolling. And here to here also there should be rolling. Actually I have told it has to be beveled. I didn't say about its details. If we have to see its details, we can see this kind of one indication. This job I have written here, I have drawn here. Here I have drawn like this and I have written here A. In drawings, if you see like this, you have to recognize this portions, more details we will get if we check the area of detail A. We have to see detail area. Come, this is detail A. This portion is small area, we can't see its view. If if it has been zoomed, how will it be? That is this one. If we zoom it, we get one drawing, that is its detail. If we check detail A, we can recognize it is having one nose, light straight portion is there, then beveled area is there, then straight portion it is going, it is also going, here also it is going from here to there, it is also going from here to there, there should be, there is a small angle, here is a small angle, in between there is a straight line. But I haven't indicated what is the measurement from here to here, what is the degree of this angle, what is the thickness of this measurement, what is the gap in between. It means in this area, when we roll, after rolling, it will make this kind of rolling and it will reach here. It indicates this one. Means one plate we will roll and it will start from here and it will be rolled, and after completing the rolling it will reach here. Okay, it's a detail. I have actually in this area, if it has been written as detail A, everything had to be written. But I am teaching you, some of you may not be able to understand, so I have written one more detail. Same thing is there. I have indicated measurements here. Here both are same. It is the thickness. Here it is the beveling. And straight portion we had seen, that's the straight portion. Again degree type of beveling, again straight portion. What is this? This 20 mm thickness is not finishing here. It is going again and again. It is going. It is having it is more length. We can't indicate it in this drawing. If we can't indicate in this drawing and it can't be scaled, we have to show this kind of one measurement indication in this way. What does it mean? It means this line, these two lines doesn't stop here, it is having more length. Same indication I have here also, I have given here also. What does it mean? This two pair lines, this indication starts from here and this indication ends here. In between two lines are going. These two lines are not finishing here. It is having more length, but there is enough place in this drawing, so we have used this indication. It is detail A. There I didn't say about what is the length from here to here. Every company will have special specification about welding. Some companies will be saying it should be 3 mm, somebody may say 2 mm, somebody may say 1 mm, somebody may say 0 mm. It is according to their own welding specification. I have just told you about teaching you only. So here also I have told 4 mm. Sometimes some companies may say, some welding specification may say it should be 3 mm. Somebody may say 5 mm or more than 5 mm. Somebody may say 2 mm or some other thicknesses, gaps. So I will be saying about this all next class. Now I stop this one. Sometimes in between my classes, because of some problems, video may be stopped unexpectedly. If it happens, you should see the full view of that drawing. Sometimes I may not have told the last things, whatever I have written. You have to just check. You have to just write in your notebook. Okay? Because last time or in its previous time, I had got this kind of machine, this kind of some faults I have got. Okay? Now I just finished this degree calculations 7th portion. Next time I will come with the degree calculations 8th portion. In that portion I will be saying about its more details. I will tell about its more details, and we can go to the next class, cons. Okay, more congested jobs are coming. I welcome all of you to see these all videos and get knowledge from these all. So many videos I have done. Actually, degree calculations, the serial of degree calculations 7 has finished only. But my total videos are more than 64. I do some other videos also. You can watch those also. In all videos, everybody used to say before starting and that time of finishing, please subscribe my channel. But in this 64 videos, if you check, you can't hear this kind of sounds. But here you can't hear these kind of sounds most of the time. Sometimes you may have heard it 2 or 3 times only in this 64 videos. Now I tell you, please subscribe my channel, because it isn't a cheating. It is for giving you knowledge. I think you get knowledge. Your knowledge will be increasing step by step. Coming episodes won't be, I am not indicating about the next episode, degree calculations 8th portion. So many episodes are coming. Those episodes developments won't be this kind of square or rectangular shaped ones. Different types of jobs are coming. It means it may not be round, it may not be a oval shaped one. We can't say there is a job, there is a creature, it is called amoeba. Amoeba type shaped jobs will come. Those all will be, I will be doing its developments and teaching you in scientific calculations and layout systems and through AutoCAD. Okay, so please subscribe, share, comment, and click the bell icons and give me more supports. I am not telling about degree calculations only. I do some other videos also. Another